Okay, folks, we're about to swim in the deepest waters of the cosmos. Let's talk about our place. So far, we know that we live in the solar system, and the solar system is on a little branch called the Orion Spur, or the local arm of the Milky Way galaxy. But our galaxy belongs to a cluster of galaxies called the local group. It's a very small cluster, only about 45 galaxies, and 42 of them are little dinky galaxies, dwarf ellipticals, and irregular galaxies. There are 3 large galaxies, and they all happen to be spirals. The largest in the group is our sort of big sister galaxy, Andromeda, M31 on the Messier list. The Milky Way is a very strong second place, and then about half the size of us is a third one, not nearly as well known, the Triangulum galaxy, M33. So no large ellipticals in our neighborhood. Lots of dwarf galaxies, as you'll see. Now, that's one cluster. A relatively nearby cluster, which is much, much larger, sort of the king of clusters in our neighborhood. If you think of our Milky Way as being a city, the local group is a state, but it's kind of like we're a big city in a fairly small state, if you will. But there are much larger states out there. For example, Virgo cluster is kind of the California of clusters, 2,500 galaxies. Just hard to imagine. Yes, we're going to see some pictures here in a moment. First, here's a little map. When I say little map, if you look at the scale here, I guess that's about an inch there, represents 1 million light years. Yeah, the light... The distance that a beam of light, a laser beam, would travel in 1 million years is now about an inch on this screen. This is just mind-boggling. But anyway, each circle here, if the Milky Way is in the center, each ring represents 1 million light years out. And you can see just past 2 million light years out, we have Andromeda, and almost to 3 million light years out, we have the Triangulum galaxy. Andromeda has a whole entourage of little galaxies like M32 that orbit it. Here in this picture, you can see the large and small Magellanic Clouds that orbit us. That's our local group. Now, let's take a look at some other clusters. Stephan's Quintet is kind of another small cluster. Very beautiful. Looks like these are really relatively close together. And there is the mighty Virgo cluster, at least part of it. Looks like it's dominated by elliptical galaxies, such as M87. And it's just hard to imagine, but every smudge on that screen is a galaxy with billions, tens of billions, hundreds of billions of stars. It's just mind-boggling. Here's another cluster. This one has a lot more spirals, it looks like. You see the spirals with the dust through them. Kind of an oddly shaped one down there. Big ellipticals here and here. In infrared, sometimes we can see even more. Some of those smaller dwarf galaxies will pop up. This is the giant Coma cluster. Another big state of galaxy cities there. Hickson 44, you see a nice barred spiral here. That would be classified as an SBC, a barred spiral with very loose arms there, SBC. Nice spiral down here. Giant elliptical here, beautiful spiral down there. And it goes on and on and on. That one apparently is giving off a lot of X-rays, so probably a supermassive black hole at the heart of that one. The Perseus cluster, one of the largest clusters we know of, and the Coma cluster. And I just want to point out, when you look at something like this, and when you see so many trillions, maybe quadrillions of stars, it's really hard to imagine that someone isn't looking back at us. How can that not be? Even if there's only a 1 in a trillion chance that intelligent life has developed at this time, there are a whole lot of trillions right there. You know, trillions and trillions of stars that you're looking at just in this one cluster. And so I don't know how you can't conclude that there's other intelligent life in the universe right now, looking back at us, probably from that picture right there. Okay, clusters aren't the largest things that we've named, though. that belongs to superclusters. Clusters of clusters are called superclusters, the largest named structures, and we live in the Virgo supercluster. So if clusters are like states, I kind of think of superclusters like countries, I guess. And so here we go. This is our home. Now, you notice there's a difference between a Virgo cluster and the Virgo supercluster. We do not live in the Virgo cluster. Just the same as you can live in New York State and not live in New York City. So the Virgo cluster is a separate cluster from us, but together, along with M81 group and the Ursa Major group and so forth, we all form the Virgo supercluster. Now, I guess for I don't know if this was as a joke or just to make a point here, but they not only did not use for the distances here, they didn't use scientific notation, and they put everything in kilometers. So look at this. The closest group, the closest cluster to us, to our local group, is M81. Look at this number: hundreds, thousands, millions, billions, trillions, quadrillions, 104 quintillion, 60 quadrillion kilometers away. Rounded to the nearest quadrillion, I assume. Yeah, it's pretty insane at this point. So that's the Virgo supercluster, and you now know your full address. So when you put your return address on a stamped envelope, make sure you mention Orion Arm, Milky Way, local group, and Virgo supercluster. All right, here's another picture. Now, on this scale, you start seeing a little bit of structure, just in the sense that you have a pattern here. You have a strand of galaxy clusters, and you have giant voids. And that's pretty much what we think the universe looks like on the biggest scales. Now, before we get to that, quickly here, we're going to see a little video here showing two clusters merging together. So we know that can happen, and obviously that would be a very intense thing and hard to predict exactly how that's going to turn out. But remember, you can have, for example, two spiral galaxies that can collide and form a giant elliptical, and in a larger sense here, you can have two clusters, merging together to form an even larger cluster. Now that brings us to kind of my second favorite term in astronomy. My favorite term is spaghettification, but my second favorite term, galactic cannibalism. When galaxies collide. Now we're back to talking about individual galaxies colliding. This was a picture, one of the first pictures really from the Hubble telescope in its early years. I remember this one from the beginning of my career. I was on the cover of Newsweek. Galaxies colliding. Here's a sort of greatest hits, no pun intended, of galaxies here colliding, different ones there. It's amazing all the different shapes and so forth that you get. Here's one that's kind of popular amongst the students. All right, so now we're getting out, and here's one you see a giant elliptical galaxy, and in an infrared you see that it has these sort of undigested chunks there of other galaxies. And yes, our own Milky Way is guilty of this. We are cannibalizing some smaller galaxies right now. Okay, and eventually they'll kind of blend in with the other stars, and we won't know which ones are from that galaxy and which ones are ours. They kind of get assimilated into our galaxy. So, on the biggest scales, what do we see? Strands and voids, long, huge strands of galaxy clusters and enormous, immense voids. Okay? Now, that doesn't mean there's absolutely nothing in the voids. I'm sure there are rogue galaxies, just like in all space. There are always particles flying around, and there are rogue planets and rogue black holes, we think, and so forth out there. The strand that I'd want you to know is the Great Wall. That one's of importance to us because guess what? We're getting sucked in towards it. Our whole local group is heading towards this Great Wall of galaxies and galaxy clusters. And again, we're going to look at a map here of these strands and voids. Here's one from the 1990s that got some attention, going out about, looks like 200 megaparsecs. So that'd be about 600 million light years. And here we have this great wall of galaxies, including the Coma Cluster. And you see that it made this little figure here that was called the Stick Man. So that got some attention there. There's the Milky Way here. And you see this giant great wall of clusters and galaxy clusters. All right. So, if you had a quote unquote God's eye view of the universe, what would it look like? Well, if I had to pick a word, the word I would pick is a cobweb. That's what it starts to look like on the biggest scales. Okay? Chunks of galaxy clusters here together. There's our Virgo supercluster, but also enormous voids in between, just like with the spider web. And you see the Capricornus void. They've named all the voids and so forth. So this is about the biggest scale map that we have of the part of the universe that we can see. And I have to point out, we can't even see all of the universe. Now, this brings us to, I'm going to end this lecture with, I think, the most important picture ever taken by the Hubble telescope. If you want to know, get some rough idea of how much stuff is out there in our universe, maybe this will give you some idea. The Hubble Deep Field, what they did was in 1995, they picked a spot just north of the Big Dipper, and they zoomed in, and they let the Hubble telescope collect light for over 100 hours. Over 100 hours with the most powerful telescope in existence. And what did they see in this little speck? There it is. What we call the Hubble Deep Field. I think the most important picture ever taken by the Hubble. In this one little speck, imagine holding out maybe a tiny little pebble on the end of your finger and holding it out and looking up at in the sky at a little dot like that. And we saw over 2,000 galaxies. These are galaxies. Every little dot on here is not a star. It's a galaxy with tens or hundreds of billions of stars. And so any little spot you pick in the sky, you're going to see the same thing. They did it again in 1997 with the Hubble. They called it the Ultra Deep Field. Same thing in a different direction. Everywhere we've pointed the Hubble, we see the same thing. You can do it with ground-based telescopes. This is from the Keck in Hawaii. The same thing. Every little dot in the sky. The very latest one from 2014. Again, from the Hubble, the latest deep field. Now that Hubble has been improved over the years, this is probably the last great deep field image from the Hubble. There it is. Any little direction you look in. So if you want some sense of how many stars are in the entire observable universe, here's what you can do. Go fill up a swimming pool full of sand. That represents the number of stars in our galaxy alone. Now, take each grain of sand out of that pool of sand, take each grain out one at a time, and give it its own swimming pool full of sand. And by the time you get done, that will give you some idea of the number of stars in the observable universe. More than every grain of sand on every beach in the world. Thanks for listening.